Alright, so in this video we're going to talk about circumference of a circle. Now what happened was, it was observed that circles had this really peculiar property. You can try this as an activity. Draw two circles which have the same center, right? So two circles with the same center, but they have different radius or different radii. And then you measure the radius of the bigger circle and the arc of the bigger circle. And you measure the radius of the smaller circle and the arc of the smaller circle. And you look at this ratio, they come out to be the same. So A over R equals B over S, which is kind of cool because it also means that if I draw a third larger circle, the ratios are going to be equal. Now, a comparison with similar triangle, you can think of these are not really triangles because one of the sides is not a straight line. But you can think of it in terms of similar triangle, where you can say that the smaller shape here is similar to the larger shape, and that's why the ratios work out. So what happens is that if you measure the circumference of a circle and you divide by twice the radius, you always get the same value, and that value is called pi. Now, pi is a special number. It goes on forever, 3.1415 and so on. For our purposes, on the calculator, whenever we do any calculations with pi, look for a button, which is, the button says pi. Always use this. Use the pi button for any calculation, because if you use 3.14, your answers will be off because 3.14 is an approximation. So from here, what you get is that circumference of a circle is given by 2 times pi times the radius r. Or another way you may see this formula written is pi times d, where d is the diameter, which at this point should make sense to you because diameter is exactly twice the radius. Now what if instead of the entire circumference, I want to find just a part of the circle, and I want to find the length of an arc. So let's start. Let's work with a circle of radius 1. Now if my radius is 1, what is the circumference? I know is 2 pi times 1, which is 2 pi. But I also know, just by observation, that this angle 1 is 360 degrees. Why? Because it is one full rotation. And one full rotation gives us 360 degrees. Let's move to the second one. If it's half a circle, then the length of this is going to be half the circumference. Right? This should make sense because it's exactly half the circle. But the radius is 1, so this is 1/2 times 2 pi times 1, which gives you pi. But on the other hand, what is this angle? It's a straight angle, so it is 180 degrees. Right? So it's a straight angle. Now notice how 2 pi got halved to pi, and 360 also got halved to 180. Let's make one more half. This is quarter circle, so it's 1/4 times 2 pi times 1, which is pi over 2, and this is 90 degrees. So once again, the length got halved and the angle got halved. So based on this, you should be able to observe that there is a relation between the value of the arc length and the angle. If I take smaller chunks of the circle, then the value of the angle seems to change corresponding to how small of a chunk I am taking. So this gives us this formula, is that, recall, central angle is an angle that lines make with the center of the circle. If you know this central angle, then you can find this particular arc length by taking the central angle, dividing by 360 and multiplying by the circumference. Which should make sense because of the discussion that we just had. So what you're saying is, you're asking what ratio of the circumference is this part of the circle, which is the same as the ratio of this angle to the full circle, which is 360 degrees. Example here. So in this case, the central angle is 65. So the arc length, which is x, is going to be 65 degrees divided by 360. That's how much of the entire circle this angle is covering, times 2 pi times the radius, which is 4.2 inches. And once again, you can try this and verify, making sure you use the pi button when you do your calculation. And it should come out to, you should get a value of approximately 4.765 inches. Another type of problem that could be asked is, find the central angle that cuts off an arc length of 3 inch on a circle with 5.2 inch radius. So you have a circle. The radius of this circle is 5.20 inches. Now you select 2 points somewhere and you select them in such a way that this length AB is 3 inches. And you're trying to find out what is this angle. So let's call this central angle, let's give it a name, let's say it's angle 1. So I know that angle 1 divided by 360 times 2 pi times the radius should give me the arc length. So now all I have to do is I have to solve for angle 1. Let's start by dividing out these numbers on both sides. Recall, this is the process by which you isolate the unknown variable. So angle 1 over 360 equals, once again, remember you have to use the pi button on the calculator. So it's 3 divided by 2 divided by pi divided by 5.20. So what I have here is 0.09182. And now this just means it is divided by 1, so I can multiply by 360 to isolate angle 1, in which case I get that angle 1 equals 33.05 degrees. So these are the two kinds of problem that you can have based on circumference formula. In the next video, we will talk about a different way of measuring angles.